Question 1, here is a right angled triangle. Work out the value of x. So with right angled triangles, there are only really two things it's going to be. It's either going to be SOHCAHTOA or Pythagoras. And there's no angles here, so the chance of it in SOHCAHTOA is rather slim. So, other option, Pythagoras, which this is, because we have two sides, we want to find the third side. So the equation of Pythagoras is a squared plus b squared equals c squared. Remembering where c squared is the longest side. So if we kind of fill this in then, so we get 4 squared plus x squared equals 8.5 squared. Then if we fill this in further, we get 16 plus x squared equals 72.25. And then if we take 16 over there to move it from this x squared, we get then x squared equals that minus 16, which is 56.25. And then if we square root that to find x on its own, we get 7.5. And there we are. That is question 1. Question 2, t is 4m squared minus 11. Work out the value of t when m is minus 3. So they're telling us that t is equal to 4 times whatever m is squared minus 11. Let's work that out. So 4 times whatever m is, and in this case m is minus 3. We're going to square that, minus 11. That's what t equals. And then, following BODMAS rules or BIDMAS rules, whatever it is that you learnt, we need to do the brackets first and the indices. We're going to do that. So we get then 4 times minus 3 squared is 9, minus 11. 4 times 9, that is 36, minus 11, which is then, what is that, 25. So t is equal to 25. And I've got my 9 times tables then, good lord. Part B, make p the subject of the formula d is equal to 3p plus 4. So currently d is the subject, so we need to kind of rearrange this in order to get p on its own. So what needs to go? So the 3 needs to move, and the 4 needs to move. If in doubt, move the one that's furthest away first. That's typically the one that needs to go first. So you take away this 4, because it's currently add, do the opposite, take it away. Then get d, take away 4 is equal to 3p. And then if we divide by 3 to get p on its own, we can get p is equal to d minus 4 all over 3. And there, because obviously these two won't divide by 3 individually, so we'll just whack it all as a fraction. And there we are. And that is then the end of question 2. On we go. Question 3, Rick, Selma and Tony are playing a game with counters. Rick has some counters, Selma has twice as many counters as Rick, Tony has 6 counters less than Selma. In total, they have 54 counters. The number of counters Rick has, the number of counters that Tony has is 1 to p. Work out the value of p. So we need to know these numbers of counters, which is going to be based off of this info here. So everything is kind of based off of Rick, we can see, because Rick has some counters, and then Selma has some counters in relation to Rick, then Tony has some in relation to Selma, so it kind of, Tony links to Selma, Selma links to Rick, and then Rick is on his own. So I'm going to make Rick equal to x. That's how many counters that Rick has. Then Selma has twice as many counters as Rick, so Selma is going to have 2 times the amount of counters that Rick has, and Rick has x counters. And Tony is going to have 6 less counters than Selma. So Selma's counters is 2x, and if he has 6 less than that, then he has 6 fewer, which is minus 6. And then in total, they have 54 counters. So Rick plus Selma plus Tony, so Rick plus Selma plus Tony, is equal to 54 counters. So let's find what x is then. So Rick is x, Selma is 2x, and Tony is 2x minus 6, and they are all equal to 54. If we then simplify all this, x plus 2x, that's 3x, plus 2x again is 5x, take away 6 is equal to 54. And then if we get x on its own, which means I need to move this 5 and this 6, but 6 is further away, so I'm going to move that first. I'm going to add this over there. I'm going to get 5x is equal to 54 plus 6, which is 60. And then divide by 5, x is equal to 12. So I then need to find the number of counters that Rick has. That's the first part of my ratio. So Rick That's one of the X, so Rick has 12, so it's 12, 2. Number counter that Tony has, so Tony has 2 lots of 12 minus 6. 2 lots of 12, that's 24, so 2 lots of 12 minus 6, whoops daisy. So that there is 24 minus 6, and that, whoops daisy, barely see it, is 18. Okay, so I now have 12 to 18. So I'm going to simplify this first just a little bit to kind of get it into a bit neater form. So I'm going to half both these, I think, to get 6 to 9, and divide both by 3 to get 2 to 3. And then what I'm going to do is this guy here, I've been told, the one on the left, has to be a 1, right? So this has to be a 1. So how am I going to get from 2 to 1? I'm going to divide it by 2. So therefore, what am I going to do over here? I'm also going to divide that by 2, which means that this is then 3 divided by 2, or 1.5. And you're not normally meant to leave these as decimals, but because it's asked for 1 to p, 1 has to be there, right? Which means that p then has to be 1.5. Not ideal, but the way that they've asked us to do it, that's the way that it must be. And there we are, and that is 5 marks. On we go. Question 4. Joe is going to buy 15 rolls of wallpaper. Here is some information about the cost of rolls of wallpaper from each of 2 shops. So from Chic Decor, it's 3 rolls of £36. From Style Papers, it's back of 5 rolls, is a normal price at £70, and it's 12% off at the normal price. Joe wants to buy 15 rolls of wallpaper as cheaply as possible. Should Joe buy wallpaper from Chic Decor or from Style Papers? You must figure out where you get your answer. Okie dokie then. So, let's have a think. So, 3 from Chic Decor, CD, 3 rolls is equal to £36. But I don't want 3 rolls, I want 15 rolls. So we can kind of treat it kind of like proportion. So how many 3s fit into 15? So how many lots of this kind of bundle of 3 do I need to buy? Well, that is 5. I need to buy 5 lots of it. Therefore, I'm going to multiply this 36 also by 5. And I am going to get 180. So from Chic Decor, can't speak, that is going to cost £180. From Style Papers, so a pack of 5 rolls normally costs 70, but it's 12% off today. So from Style Papers, so this is how much 5 rolls cost. So 5 is £70, but we only need 5, we need 15. So I'm going to then times the price for 5 by 3. So that is also going to times by 3 to get £210. However, it's 12% off. So what I'm going to do is find 12% of £210. So you can either times it by 0.12 and take it away, or times it by 0.88, which will take it away for you. Or you could do kind of the classic of find 10%, which is 21, then find 1%, which is 2.1, double it to get 2.4, double it, 2% to get to get 4.2, I should say, one way round, and then add those two together, 21 plus 4.2 to get 25.2, then take that off. Either or, I mean, that's kind of the method I've gone for, isn't it? The 210 take away, what is that, 25.2, which is just 10% plus 2% to get 12%, which is then, so that is £184.80. These are my 2 answers, £180 and £184.80, which means that Jo should buy her wallpaper from Chic Decor. And there we are, and that is that. Question 5. The table gives information about the lengths in centimetres of some pieces of string. Amos draws a frequency polygon for the information in the table. Write down 2 mistakes that Amos has made. So typically when you have a spotting a mistake in a graph question, the 2 mistakes that they want you to highlight are kind of normally always the same. Obviously there's always exceptions, isn't there? But typically one of these points will be plotted wrong. So either that one, that one, that one, that one, that one. They'll just be in the wrong place. And something will also be wrong with the axes. Again, I have something else in this question, but let's check those first because typically it is those. So if we check the axes first, we've got 0, 10, 20, 30, 40, 50. That's fine. and then we've got 10, 20, 30, no 40, and then kind of goes on from there. So that's one of the points. So 40 is, oops, that's is missing from the y-axis. Okay, that's 1 point. And then let's check if the points are plotted correctly. So it's a frequency polygon, which means that the interval is like the middle of the interval is plotted. Edge if it's cumulative frequency, middle if it's frequency polygon. So we have, let's have a look. This one is 5, and then 15, so that's right. This one should be 15 and 20. 15 and 20, that one's perfect. 25 and 50. 25 and 50, yep. 35 and 40, 35 and 40, yep. I mean, they're missing 40, but that is technically correct on their graph. And then 45 and 50, 45, this is the 50, and 5, I should have said earlier, I think. This is the point that's wrong. That guy is a wrong one. So this point, so the 45, oops, daisy. 45 points has been plotted incorrectly. Then you can put, they have instead plotted 55 instead. And there we are, that will be 2 marks. On we go. Question 6, Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Give your answer in miles per hour. So we've been given speeds, times, distances in the question, which means that it's going to be the kind of infamous equation. Speed is distance over time. So let's start with what we know first. Let's start with this kind of top line up here. Actually, I'm going to star it in a different colour so we can kind of decipher which part is on which bit. So this top line I'm going to do in purple. Let's go around to 15 minutes at an average speed of 6 miles per hour. So all our times have to be in hours. So speed is 6 miles per hour. Distance, we don't know. Time is 15 minutes, but that in hours, like a quarter of an hour. So 0.25. I could put it as like just a quarter, like 1/4, either or. So therefore, we can now work out the distance. So the distance is 6 times 1/4. So the distance is 1.5. Okay, so that's that. So in this section, she runs 1.5 miles. And there we go. Next section then, if I use red, because why not? She then runs for 40 minutes at an average speed of 9 miles per hour. Let's do the same thing. So then she runs 9 miles per hour. We don't know the distance, but the time is whatever 40 minutes divided by 60 is getting into hours. So 40 divided by 60, that's 2/3. I'm going to keep it as 2/3. So it's going to be a recurring decimal. So I then can work out the distance. So distance is then 9 times 2/3, times that up there. Same thing I did over here, times that up there. 9 times 2/3, which is 6. There we are. So in this stretch, she runs 6 miles. Okay. And then it takes, let me get that in blue. It takes Amy 45 minutes to run the same total distance that Jessica runs. Okay, so we don't know the speed. That's what we're trying to work out. So we then know distance is the same as Jessica runs. So Jessica has run for 6 miles and 1.5 miles. Therefore, that's 7.5 miles. 7.5. And then it takes Amy 3/4 of an hour, 45 minutes. So that's 0.75 for time. And if I divide those two, 7.5, oops, daisy, 7.5 divided by 0.5, and I get 10. So Amy's average speed in miles per hour is 10 miles per hour. And there we go. And that is that. 4 marks. On we go. Question 7. The diagram shows rectangle STUV, TQU, which is this line here, and SRV are straight lines, all measurements in centimetres. The area of trapezium QUVR, so the shaded one is A. Okay, so the A is 2x squared plus 20x, which means find the area of A, that's all. So we need to find the area of this guy. So we don't know much about this section. We don't know that line. We don't know that line. Well, technically this is 4x, isn't it? It's a rectangle, so we know that. So what we could do is work out the total area of this rectangle and then take away the white area. That sounds like something we could do. So let's do that. So area of the total rectangle. So I might do that in a different colour. Also colour-coded on the diagram as well, until you see. So the area of the rectangle is going to be length times width, which is 4x multiplied by all of this length, which is 3x plus 5. Remember, that needs to go in a bracket. 3x plus 5, because 4x is multiplied by all of this, not just the 3x and not just the 5. Then we can kind of rewrite this as 4x lots of 3x plus 5, which then gives, if we kind of expand all this, we get 12x squared from this times this. Then from that, we get plus 20x. And that is that. And then we need the area of the kind of white trapezium. So I'm going to colour code that too. Okay, I think I'm going to kind of put this over here in this little section. So the area of that trapezium, remember the area of a trapezium is a half A plus B H, where A and B are the length of the two parallel sides and H is the distance between them. So we then have a half lots of A, which is 2x, plus B, which is 3x, times H, which is 4x. Okay, I times that there. And then what I'm going to do is do the half times the 4x. I'm going to do this in any order, all this timesing, because I don't really want to times this by 3. I'm going to get a decimal, which is not as nice. And this just makes 2x, isn't it? Half times 4x. Then I'm going to get 2x, lots of 2x plus 3x, which actually I can simplify this, can't I, to get 2x, lots of 2x plus 3x is 5x. Okay, and then 2x times 5x, that's 10x squared. Okay, and then how do I find this shaded region? Well, I need to do the green area, which is all of it, and get rid of this purpley bit, which means I'll be left with the grey bit. So if I do that, let me move it down a little bit. So I'm then going to take the green area, which is 12x squared plus 20x. Now I'm going to take away the purple bit, which is 10x squared. And that's going to give me 12x squared minus 10x squared. That's 2x squared plus 20x. And that is exactly what it wanted. Let me just kind of arrow it and tell them that's the area of A. Actually, I might as well just make it equal to A, hadn't I? What am I doing? Equals A. I'm going to underline it so that I can see it really clearly. And there we go. And that was 3 marks. On we go. Question 8. An electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of electricity he has used. Work out the gradient of this straight line. The gradient is the triangle. I'm going to use a different colour, make it less kind of, or easier to see. So you want to try and make your triangle kind of as big as possible without it being kind of awkward, right? So I could just do the whole thing, but this line up here kind of meets at an awkward spot, which I don't really want to read particularly, but this point here is quite nice, so I'm going to go with that one. Oops, easy. That's not straight line, is it? So it doesn't really matter which point you pick, any point will give you the same answer. It's typically better normally to do bigger ones, because it's normally easier to read, but not in every case, like in this case. I'm going to make it a little bit smaller to make it easier to read. And then my change in y, which remember, gradients, oops, daisy. Remember, gradient is change in y divided by change in x. And my change in y is that 12, 13, 14, 15, 16. So that's 14 divided by my change in x, which is 100. So I'm going to have 14 divided by 100, which is 0.14. And then what does the gradient of this line represent? Well, if we think about it, this is telling us that they're charging us £14 for 100 units of electricity. And because we've divided them, we've then essentially found what it is for 1 unit of electricity, if that makes sense. Because we know that £14, that's 100 units. Then because we divided by 100 to find this, if we divide both these by 100, we get 0.14 pounds is 1 unit. So therefore, the gradient is the price for 1 unit of electricity. And there we are. In total, that question was 3 marks. On we go. Question 9, express the square root of 10 to the power of 360 divided by 10 to the power of 150 times 10 to the power of 90 as a power of 10. So, remembering that the rules of indices, if you're timesing powers, you add them. If you're dividing powers, you subtract them. So, what I'm going to start with is these two down here to simplify the bottom of this fraction. So then I'm going to get square root of 10 to the power of 360 divided by 10 to the power of 150 plus 90, which is going to be 240, 10 to the power of 240. And then I can then divide these quite easily just by subtracting them. I'm going to get square root then of 10 to the power of, if you take these away, 120. And then the square root is just to the power of a half, remember? So we get 10 to the power of 120 all to the power of a half. That's what a square root is, just the power of a half. And then from there, we have another rule of indices. How many do I have in one question? You have power of power. If you have power of power, you times them. So we're going to do 120 times a half, which is 60. Therefore, we have 10 to the power of 60. And that is your answer to part A. Then part B, Liam was asked to express 12 to the power of 50 all squared as the power of 12. Liam wrote 12 to the power of 50 all squared is 12 to the power of 50 squared, which is 12 to the power of 2500. If I got this wrong, explain why. For reasons up here. Remember, power times power, a power of power, you times them. So Liam should have times those two together. Multiplied 50 by 2 to get 100. And there we are. And that overall was 4 marks. On we go. Question 10. Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. Value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010. Work out the value of the car when Jane bought it 3 years ago. So this is a depreciation question because it's depreciating in value is this car. So we start with kind of like the standard equation for compound interest and standard form and depreciation. We get the initial investments, which we don't know, so we'll call that X, times that by the multiplier. So let's have a look. So find the multiplier. You always start with 100%, with 100%, and you either add or subtract the percentage depending on whether it's interest or depreciating. This is depreciating, therefore we're going to subtract it. So for the first year, we're taking away 12.5%, which will give us 87.5%. And then to make it into the multiplier, I make it into a decimal. Just going to divide it by 100. So 0.875. And then that is then equal to whatever it was at the end of the first year, right? However, we don't know that. We just know what it was at the end of all of the years, the 3 years. So what we can then do is just kind of keep adding on. So that was the first year. That's the first year. The second and third year is the same as each other. So second and third. We work out the multiplier in the same way. So you start with 100%. Then you're taking away 10% for each year of those 2 years, which is then 90%. Divide that by 100, you get 0.9. Therefore, it's been depreciated by 10% to get 0.9 twice. Therefore, I'm going to square it. And that is then equal to £17,010. Then if I neaten this up a bit, I'm going to do 0.875 times 0.9 squared. Getting probably a really nasty number, I do indeed. X times then, if I times these two together, 0.70875 equals 17,010. And then to get X on its own, I'm going to divide this down here to get X is equal to 17,010 divided by 0.70875, which is 24,000. Which, because it's such a nice round number, I'm going to assume is correct. So £24,000. And there we are. That is 3 marks. On we go. Question 11. Raheem has 16 shirts, 5 pairs of jeans and 3 jackets. Raheem chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans and 1 jacket. Work out how many different outfits Raheem can choose. So this is a product rule for counting question, which means that you just times them all together. Easy peasy. So you do 16 by 5 by 3. Same thing every time. You have these options. Normally it's either you're picking outfits or you're picking like meals at a restaurant. Like it'll tell you how many starters there are, how many mains, how many desserts, and how many like options you can pick for a meal. Always the same. So you times them all together and you get 240. And there we are. Very nice topic. Maths Genie has a bunch of questions on it if you want to practice some more. And it comes up a lot as well. I think it comes up in like 35-40% of like papers, normally in the middle section, like question 11 through to question 17. So very good questions that I get good at because it's very quick and easy relatively, and it comes up so often as well. So yeah, that's product rule for counting. On to question 12. Question 12. ABC and ACD are right angled triangles. DC is 8, angle 8, DC is 45, angle ABC is 20. Work out the length of AB, which is this guy there. Okay, so we've got 2 right angle triangles. Like I mentioned at the beginning, it's only going to be one of 2 topics. It's going to be SOHCAHTOA, it's going to be Pythagoras. Because we had Pythagoras earlier, chances are it's going to be SOHCAHTOA, right? So let's make a start then. So what do we need for SOHCAHTOA? We need this length to answer the question. So for SOHCAHTOA, if we have an angle, we need one other length to find the other length, right? So we need one of these. So that's kind of the game plan. We've been given this other triangle, so we could find this AC length with this triangle and then use that length in this triangle. So let's do that. So I'm going to kind of color code it again. So I'm going to do everything to do with this kind of little triangle on the side, this ADC, in purple. Okay, so let's have a look then. So let's label our triangle. So we have opposites, hypotenuse, which is the longest side, and adjacent, which is 8. Because we're looking for O, we can assume that has to be there, therefore O has to be there. And we also need A, because that's the one with something written on it. Therefore that's tan for TOA. So we then have tan of 45 is equal to opposite over adjacent. So therefore tan 45 is opposite over 8. So if I times up by the 8 to get opposite on its own, I get 8 times tan 45, which is opposite, which is 8. Well, would you look at that? Easy peasy. 8. So then this length here is 8 centimeters, which I can then use in my other bigger triangle, the ACB one. So I need to find the hypotenuse of that triangle. If I write that out, I need to find the H, and I know the opposites, which is 8. So that's going to be SO, because I have S, and then I always have one of these, and then O and H. O is what I have, and H what I want to find. So then I have sine of 20 is equal to O, which is 8, over H, which we don't know. And then I want to get H on its own, but it's in a really awkward spot here, so I'm going to times it up first, just kind of move it to a better position. So I'm going to get H times sine 20 equals 8, and then divide down by sine 20 to get H on its own. So then H is then 8 divided by sine 20. Therefore, H is 8 over sine 20. 23.3 significant figures 4. And there we are. And that is the final answer for how many marks? 3. And there we are. On we go to question 13. Question 13, A and B are vectors such that A is 2 minus 3 and 3A minus 2B is 8 minus 17. Find B as the column vector. So interesting. So 3 lots of A minus 2 lot whatever B is, whatever that may be, is this. So if we find 3A, that's then kind of part of this puzzle, right? So 3A and my column vectors are easy peasy. Manipulating those, easy peasy lemon squeezy. All you need to do, times it by 3, is just times both the numbers by 3. Easy peasy. So that's going to get 6 and minus 9. So that's 3A. So now I know that 6 minus 9, take away 2B, is this guy over here, 8 minus 17. Okay, and then what we can do is just rearrange this to get 2b on its own. It looks awkward because it looks like it's a big old mess, right? But this, you can treat pretty much anything in maths like algebra. So I'm going to rearrange it just like this was x and this is y. I'm going to try and get b on its own. So I'm going to add 2b over here for now, just because it's minus, which is kind of annoying. So I'm just going to move that. So 6 minus 9 is equal to 8 minus 17 plus 2b. And then we're going to take this over here, subtract it, move it over there. Then 6 minus 9, take away 8 minus 17 is equal to 2b. So then if we kind of solve this, again, easy peasy column vectors, you just take them away. Even easier than fractions if you get the sub bottom the same or anything. Easy peasy. So 6 minus 8, that's minus 2. And then minus 9 minus 17, what is that? That is 8. Okay, because I'm just adding them because it's minus minus, therefore plus. That is then equal to 2b. Well, if 2 lots of b are minus 2, 8, one singular lot of b is going to be just half of this. If we divide both these numbers by 2, we're going to get minus 1, 4. And that is your answer. And that is 3 marks. On we go. Question 14a, factorise fully 4p squared minus 36. So what I always do first is pull out anything first into like a single bracket and then do the brackets later if I need to. But I can pull out something from both of these. So I'm going to pull out a 4. So I'm going to have 4 lots of p squared minus 9. Then I'm looking and think, okay, can this be factorised any further? And yes, it can, because this is a difference of 2 squares. Important to spot, it's a square number, take away another square number, therefore difference of 2 squares. So the way we factorise those is, it's kind of always double brackets, and then in the first one you always put whatever this is kind of square rooted almost, so then you get p and p. Same thing for this over here, square root that, you get 3 and 3. Technically square root of that, you get both plus 3 and minus 3. So that is then your final answer, 4 lots of p plus 3, p minus 3, and there we are. Then part B, show that this triple bracket situation can be written in the form of this big old messy situation where A, B, C, and D are integers. Okay, so with expanded triple brackets, I normally like to start with the first two. You kind of ignore this third guy is here for now, and then go back to the third guy after that point. So I'm going to expand just these two for now. So m plus 4 and 2m minus 5. If I expand those, I get m times 2m, which is 2m squared, m times minus 5, which is minus 5m, 4 times 2m, which is 8m, and 4 times minus 5, which is minus 20. And if I simplify this, I get 2m squared minus 5m plus 8m, which is 3m minus 20. Okie dokie. And then this forms another bracket that I'm going to put the times next to this one. So I'm going to have 2m squared plus 3m minus 20. Put it in different colours so it's easy to kind of see the different steps. And then that's going to times by 3m plus 1. So I always go in the same order for this. It's kind of like a pattern that you can follow. So I always start with the first term and then times that by both of these. So if I do that, I'm going to shuffle this downwards a little bit. I'm going to get 2m squared times 3m, which is 6m cubed. Then 2m squared times 1, which is just 2m squared. So that's that one then done. And then we'll move on to this guy. So this guy times that guy, which is 9m squared. Then this guy times that guy, which is plus 3m. Done. And then minus 20 times 3m, which is minus 60m. Then minus 20 times 1, minus 20. So it kind of goes in a nice order. And then it's also an order down here. It goes a cube, and then 2 squared, and then 2 m's, or whatever letter you have, and then a number. That's then always the same no matter what. So doing it this way, kind of having a structured approach to it, would mean that it's more easy to spot when you've done something wrong, if you've missed a term, something like that, because you should always get this. Cubed, 2 squareds, 2 letters, a number. Easy peasy. And then simplify, right? So we get 6m squared, 6m cubed, sorry, he's the only cube, so I'm going to leave him be. And then 2m squared plus 9m squared, that's 11m squared. Then 3m minus 60m, that's minus 57m minus 20. And that is your final answer. There we are. On we go. Question 15. P, Q, R, and S are 4 points on a circle. P, X, R, and S, X, Q are straight lines. Prove that triangle P, Q, X and triangle S, R, X are similar. Okay, trying to test my whether I can say letters in an order. Right, so we're trying to prove that this guy here that I put in black pen is similar to this guy here, which I'm going to put in blue pen. Okay, but similar means same angles, different lengths, right? So the lengths can be anything. Obviously, this triangle is obviously smaller than this triangle, right? But the angles may be the same. So can we spot any angle rules that would tell us that these guys are the same? First one I'm spotting is that these are opposite angles. It forms an X in the middle. So this guy and this guy are equal. So I would then kind of write a sentence about that, but I'm going to kind of go through the angles first and then write it all out second. Because actually, technically, the second rule is the same for both of the other angles. So this angle here and this angle here are both equal, as you might be able to probably imagine, and this one and this one. Reasons why, because it's a circle theorem. Do you remember the circle theorem where it's the where it's like angles in the same segment are equal? So these two are equal and these two are equal because they're both angles in the same segment. The segments, this segment kind of being this side over here and this side over here. So these two, the yellow angles and the purple angles, they have the same reason. Happy days. Let's write all that out and then I'll kind of talk you through it. Okay, and then these are your 3 reasons. So the red angles are equal because they are opposite angles. And then the yellow angles are equal because angles in the same segments are equal, and the purple angles are also equal because angles in the same segments are equal. Again, times 2, the remix. And there we are, and that is that. Oh my god then, that was 3 marks for this question. Oh my god, it's question 16. Question 16, P is equal to the square root of 2e over f. E is 6.8, correct to one decimal place, and f is 0.05, correct to one significant figure. Work out the upper bound for the value of P. If your answer correct to 3 significant figures, you must show all you're working. Okie dokie. So with bounds, find the upper bound. If you've got a fraction like we have done here, on the upper bound, it's where they're kind of stretching apart, which would make if you kind of imagine zooming in, you would zoom in to make something bigger by going like that. If it was the opposite, finding the lower bound, you would kind of pinch it to get smaller, if that makes sense. That's kind of how I always think about it. So if you're finding the upper bound of this, you want to have your kind of opposite of a pinch, kind of expanding it like that, which means you want to have the top one, the upper bound on top and the lower bound underneath. So let's find the upper bound of E and the lower bound of F. So what I normally do for that is I put the kind of number that we have in the middle, and then I take one and add one from what they've rounded it to, so this guy. So I'm going to take one from that to get 6.7 and add one to get 6.9. And then I need the upper bound, which is this middle section here between like the upper one, the one I've added one thing to, and the middle, which is then 6.85. So if I start filling in my equation, I'm going to have upper bound P is equal to the square root of 2 lots of 6.85 divided by the lower bound of F, which is 0.05 in the middle. And then take one and add one, so 0.04, 0.06, and then middle of here, 0.045. That's then going to go down there, 0.045. And then all I need to do is type it in my calculator. Easy peasy, lemony squeezy. So if I pull that in, I get 17.448. Into 3 significant figures, that's this guy here. That's going to stay as it is because this guy's smaller than 5. Therefore, I'm going to get 17.4. And that is my answer. And there we are. Oh my god, then to question 17. Question 17, the table gives information about the distances in miles that some year 10 students live from school. On the grid, draw a histogram for this information. So they've already given you that it's frequency density on here, which is nice of them. So it's just a case of remembering what frequency density is. So frequency density is frequency divided by like the width of an interval, the class width. So if I write that out, let's have a little equation for it, which I'm not going to put there. That's a really poor place. I'm going to write it over my face soon. So frequency density is equal to the frequency divided by the class width. And there we go. And that is that. So then to find the frequency density, I'm first going to find the class width, which is just kind of the difference between these. So between 0 and 1, that's 1. Between 1 and 1.5, that's 0.5. 1.5 and 2, that's another 0.5. 2 and 3, that's 1. 3 and 5, that's 2. And then I'm going to divide the frequency by all of those. So 90 divided by 1 is just 90. That's the frequency density. 48 divided by 0.5, just double it, which is 96. 22 doubled is 44. 8 by 1 is 8. 12 by 2 is 6. Okie dokie. So then these are the numbers that we need along here. Quite a large range, as we can see. Let's have a look. We can go up in tens. 10, 20, 30, 40, 50, 60. We cannot. 10, 20. If I go up in 20s, 20, 40, 60, 80, 90, 100. Yeah, that looks like our only option, isn't it? So we'll go up in 20s. So that's 20. Okie dokie. So what we then need to do, remember, histogram is kind of like a bar chart, but all the bars are like squished together. So let's start drawing that. So we have, I'll draw the first bar, don't worry, I'll just make you watch all of them. And then I'll kind of fast forward. So the first one is class width between 0 and 1 mile, and then frequency is up to 90, which is up here. Doop, 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 and that's how you draw all the bars. So I'll kind of draw the rest of them, and I'll show you what it looks like. And there we are, and that is your histogram. So looking something like that, and there we are, on we go. The histogram below shows information about the distances in miles some Year 11 students live from the school. Okay. The number of Year 11 students who live between 1 and 2 miles from school is n. Find an expression in terms of n for the number of Year 11 students who live between 3 and 5 miles from school. Okay, so they've told us that the frequency of the number of students who live between 1 and 2 miles is n. Remember, frequency is if you multiply the frequency density by the class width. That's equals to frequency, using kind of the equation we saw on the other question. If I go back one, this equation here, just times that up there to get frequency on its own. So that is then kind of the area of a bar, right? Because that's the class width times by the frequency density, which is then just the area of a bar. So between 1 and 2 miles, that's this bar. So that makes that n, right? And because the class width is just 1, also to get a frequency of n, the frequency density must also be n. Does that make sense? So this guy must be n, because then n times 1 is n, right? So find an expression in terms of n for the number of Year 11 students who live between 3 and 5 miles from m. Okie dokie, so here, that's a gap of 2. So we're trying to find the frequency, right? The number of students in terms of m. The frequency is a class width, which is 2 multiplied by the frequency density. So we need to try and find the frequency density at kind of this section there, right? So how are we going to do that? So if this up here is n, what is each square worth, right? So you've got 5, 10, 15 squares to make up m. So each square is essentially 1/15 of n. Right? That's how much one square is worth. So if you added up all these 15, you eventually would get n, right? So therefore, you then have 3 of these squares. So you have 3/15 of n, which means that if we times those together, 2 times 3/15 is 6/15 n. And that, oops, you almost can't see it. There we are. That is then your answer. Tricky question, very tough. Only 2 marks, which I think is a bit harsh for kind of I guess it wasn't much work, it's just tricky, isn't it? But there we are. Hope that all made sense. If it doesn't, I'll try and explain it again, I guess, in a different video. But there we are, moving on. Question 18 here is a prism A, B, C, D, S, P, Q, R. The base ABCD of the prism is a square of side 14 centimeters. T is the point on BC such that BT to TC is 4 to 3. Okay, the cross section of the prism is a trapezium of area 147 centimeters squared. Okay, CR is 12. Okay, find the size of the angle between the line ST there and the base ABCD there. So he wants us to find, if I draw a little line across, because I might, well, actually, hadn't I? If I draw a little line, always aim for triangles. You could do like that, but that's not a triangle, so that doesn't help no one. So I'm going to draw like this, going with this angle here. Looks like it's changing on mine. Finds the angle of like the line, because this is now a slanted line, like going like this. It's no longer straight. But this angle between this dotted line and this plane is going to be the same no matter where on the plane you are. If you kind of look, the angles aren't like changing. It looks like it is, but it isn't, trust me. So there we are. So this is the angle we're trying to find. This guy there. Okie dokie. So what do we need to find that angle? Well, we need, for SOHCAHTOA, at least 2 lengths on this triangle. Currently, we have none. Bummer. So let's look at what we can find. Okay, I've been told this area intrigued me. I haven't seen anything like this in one of these questions before, so I'm going to go to that first because that's intriguing. So the cross-section of the prisms in the shape trapezium of area 147. This guy here being the cross-section. So what can we find from that? Let's have a think. So remember, the area of trapezium is a half A plus BH, right? And where A and B are the parallel sides, which is going to be this guy and this guy, and then H being the height, which is going to be 14. So if we work out kind of backwards, now the area is 147, equal to a half of A plus B. B we know is 12 because it's the same as that guy back there, isn't it? So that's 12. We don't know what A is, this line, like PA or SD, which is quite convenient because then if we have one of the lines of our triangle, that's convenient, right? Don't know what that is yet, but we do know what RC is. That's 12. Times that by 14. So then we have 147. So I'm going to move it down now. 147 is equal to a half times 14 is 7, which is then 7 lots of 8 plus 12, which is 147 is equal to 7a plus whatever 7 times 12 is, which is 84. Then I'm going to take away 84. So 147 minus 84 is 63. I'm going to move it down again. Go back up in a second when we do the rest of the question. Is 7a. Divide 63 by 7 and we get 9. So a is equal to 9. Okay, intriguing, intriguing. Right, so then PA and SD, they are both 9, which is handy because for our kind of right angle triangle that we're kind of aiming for, if I draw it over here, we want to find this angle here, this angle there, right? So we're looking for that guy. We currently have this guy as 9, with that being S, that being D, and that being T. So we need either this length here, which is kind of in the middle of nowhere. So, I mean, if we could find that, that'd be nice. But it's kind of floating randomly in the middle of the shape. So the chances of finding that, I think, are quite slim. This guy down here being on the base, I think that's slightly more likely, right? So let's think about the other bits of information that we have. So the base ABCD is a square. Gotcha. T is the point on BC such that BT to TC is 4 to 3. So, okay, so if this is 4 to 3, remember we know the length this side, we know it's 14. So we can just share 14 immediately into that ratio, right? Because we know that this is 7 pieces. So therefore each of these pieces are 2 each, right? Because it's 4 plus 3, 7. And if all the length is 14, you split it into 7 pieces, 2 each. Therefore, you get 4 times 2, that's 8. And then 2 times 3, that's 6. 8 plus 6, 14, right? So it seems more confusing than it is just because they've given you a kind of a random ratio. They don't really need to give it to you. They've already given you that length. They're trying to make it harder. That's all they're trying to do here. That's their aim with that section. But there we are. So now we know that's 8 and that's 6. This being 8 is pretty much I'm going to say relevant to me, because I don't know what the area of this trapezium is here. I only know the area of that guy. And I don't know what this guy is here. So actually, no, that's 14. But I kind of want this dude, and I can't really find that just by using any trapezium stuff, because A and B I can find, but that is neither, right? So I'm a bit stuck with that. But this guy here is a right angle triangle. I've kind of put that behind the 6. This is the right angle triangle. So if I know that this length here is 6, this on the back is going to be 14 because it's a square all the way around. So I can use Pythagoras. 14 squared plus 6 squared is that squared, right? So if I do 14 squared plus 6 squared, that is going to equal dt squared, right? So 14 squared plus 6 squared, let's work that out. 14 squared plus 6 squared, that is 232. 32, and that is dt squared. So if I square root that, I'm going to get dt, which is, I'm going to leave it as 258 for now, because the decimal is annoying. So I'm going to leave it as 2 root 58. Then I know that this length down here is 2 root 58, which means that this length down here is 2 root 58. Okay, and now it's SOHCAHTOA time, isn't it? So that is opposite. This down here is adjacent. That's what I'm trying to find. So I'm going to use TOA, tan, because I have O and A. So then it's tan of x is equal to O over A, O being 9 and A being 2 root 58. And to get x on its own, I have to inverse tan. So tan minus 1 of 9 over 2 root 58, which is, what a fun question while I type this in. You don't normally get stuff like this. This is really cool. I like this question. This paper's been really fun so far, if you guys agree with me. But I really actually enjoyed this paper so far. Nothing kind of really annoying, and just some solid questions, I think. Let me shuffle this downwards. I got the angle as being 30.6. And there we are. And that would be 5 marks. So a hefty question. And it is tricky. Trickier than they normally do for this 3D trigonometry situation. This area is new. Hasn't come up before in a question like this, which is exciting. Tricky. You have to know the area form of trapezium, which not, I don't know how many students do. A handful probably, not loads there. And then this ratio pop question, like this part of it, also probably trip people up because it's kind of just there for fun. Like there's no relevance. They could have just told, I've already told you it's 14. They could have told you the length of this, to be honest. They're just adding in a grade 4 kind of bit to it for seemingly no reason, because your brain's now in the mode of like grade 7, grade 8 question like this is grade 8. This kind of grade 4 stuff might chip you up. You might think, oh, how do I do that? I don't understand how to do that. Whereas if this was like question 3, you'd have been fine, right? It is awkward. I think a bit harsh, to be honest, but alas, I guess to be able to do grade 8, you have to know how to go for grade 4 stuff, I suppose. But there we are. Fun question. I enjoyed that. Let's see what's next. We move on to question 19. Question 19, show that 3x over x plus 2 minus 2x plus 1 over x minus 2 minus 1 can be written in the form ax plus b over x squared minus 4, where a and b are integers. So, algebraic fractions, I love an algebraic fraction question, they're my favourite, I love algebraic fractions. Let's get into it. So, we're subtracting fractions. By subtracting fractions, we need the common denominator. We're also subtracting a number from those fractions. So I'm going to make it into a fraction and then make all of them have the same denominator. That's my job thus far. We're going to put that over 1 to make it into a fraction. And then to get the common denominator, what I'm going to do is just times all the denominators together. So I'm going to times x plus 2 by x minus 2 times 1. But that's not going to change anything, is it? So I'm going to leave it as it is. And that is going to become the kind of denominator for all of my fractions. And I'm going to have 3 of them, including that 1 on the end. X plus 2, x minus 2. Okay. And then I need to figure out what I've times the bottom by and times the top by the same thing. So 3x, I've times the bottom by x minus 2. So I'm also going to times the top by x minus 2. Okay. The middle one, I've times the bottom by x plus 2. So I'm going to times top by x plus 2, 2x plus 1, x plus 2. And the bottom of the third one, I times by x plus 2x minus 2, because that was one that only had 1 down there. So also times the top by that as well. X plus 2, x minus 2. Very tempting to cancel these out, but remember that wouldn't make nothing, that would make 1, which is back where you started. So we're going to leave that as it is. And then I need to start subtracting all these. I could just go in one big order and just kind of make it one big conglomerate fraction where all this top is over just one of these down here, but that's going to look messy, I think, so I'm not going to bother doing that. I'm going to expand it all first, I think. It's kind of personal preference at this point. I'm going to expand it all, make it into more sensible terms, I think. So if I expand this top, I'm going to get 3x squared minus 6x, minus 6x. Bottom's going to keep as it is. Can't bother to expand that right now. It's going to be x squared minus 4. I mean, it's already told me, actually. So I'm going to leave it as that. X squared minus 4. Take away, expand this. 2x squared times x, or 2x, sorry, times x. 2x squared. 2x times 2 plus 4x. 1 times x, which is just 1x. Add that to this 4 to get 5x. 1 times 2 is 2. Divided by this x squared minus 4. Take away x times x, x squared, x times minus 2, and then plus 2 goes away, and then minus 4 over x squared minus 4. Okie dokie. Then what do we have? Then we can take them all the way from here. So you have to kind of go in order, remember. So take them away, because this is very tricky, because a lot of students will think, I'll just go backwards. Like I'll take this from there, like this from this, then take all of that from this. But you can't go in that order. It's like the same as 2 minus 5 minus 3. You've got to go in order. You can't take 3 from 5 and then that sum of that from 2. That's going to give you an answer that's weird and too small, right? Because then you're making this number smaller rather than just going in order. Uh-oh. So yeah, can't do that. So I need to lock this, I think. There we go. So I'm going to go in order. So I'm going to do 3x squared, take away 2x squared, leave me with x squared. Then I'm going to do minus 6x minus 5x, which is minus 11x. Then I'm going to do plus nothing, take away 2, which is minus 2 over x squared minus 5. We're taking away fractions, bottom says as it is. Then that is take away x squared minus 4 over x squared minus 4. Shuffle it downwards. Which is, take this away, x squared minus x squared, they disappear. Minus 11x, take away nothing, is minus 11x. And then minus 2 minus minus 4 is minus 2 plus 4, which is plus 2 over x squared minus 4. Therefore, A, which I referenced up here, is minus 11, and B is 2. What a fun question. I'm very much enjoying this paper. 4 marks. There we are. What a fun little question. Love algebraic fractions. On we go then. I'll stop rambling. Question 20. On we go. Question 20. The profit made by a shop increases each year. The profit made by the shop in the year N is PN pounds. Given that the profit made by the shop in the next year is pounds PN plus 1, then PN plus 1 is A lots of PN plus 800, where A is a constant. The table shows the profits made by the shop in 2018 and in 2019. Work out the profit predicted to be made in the shop in 2021. Okie dokie. These sorts of questions, they're technically classed as iteration, but I think they're very similar to like percentage increase and decrease, right? It's profit at the end of the day, kind of percentage profit almost. So let's have a look. Remember this notation, this just means that they've made this much in the year N, and then PN plus 1 is how much they've made then in the next year, right? So first the place I want to go is I want to find what this A is. This constant here, I need to find that first. Let's plug in some numbers. So we know that kind of initial N, if we say that N was like 2018 initial, the profit made in 2018 was 24,000. So N plus 1, remember N was then 2018, so N plus 1 is going to be 2019, from there is there. So I'm going to have 29,600 equal to A times 24,000 plus 800. Hope that makes sense, because that's just like profit made in the first year that you're looking at, the profit made in the next year that then you want to look at following the year that came before it, which is just here. So that's 2018, and this is like the year on 2019. Then we just kind of sort this out. Take away 800, so we get, what is that? 28,800 is then equal to 24,000 times A. Divide that down there, I get 28,800 divided by 24,000 to get 1.2. Okay, so then that's A. So what this is then saying in this equation is that the profit in the following year to this year is essentially 20% bigger, 1.2 times 20% bigger, plus another 800. That's all that means, right? Then we can use this to kind of feed our way through. So if we know that the profit in 2019, if we made that 20% bigger by dividing by 1.2, then adding 800, we will then have the following year, which is 2020. So profit in 2020 is going to be 1.2 times profit in 2019, which is 29,600 plus 800. If I shuffle this downwards, I get the profit in 2020, I get 36,320 beaners, and then what I need to do from there to find 2021 is the same thing. So it's find profit in 2021. That is then 1.2 lots of the profit in 2020, which is 36,320 plus 800. If I times that by 1.2 and add 800, I then get £44,384. And there we are. That is that. And that is 4 marks. On we go. Question 21. Ray has 9 cards numbered 1 to 9. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards and records the result. Work out the probability that the result is an even number. So before I get into it, this question and the next one actually have formed videos on my TikTok channel. So on my TikTok, just to plug my TikTok a little bit, I've been like every week I will highlight a different like really difficult question. So if you want like a challenge for you to do over Eurovision, you know, then have a look at my TikTok, because there's a big kind of set of videos all about like really challenging questions where I'll kind of post the video on the question, see if you can get it, and then another video on like me walking you through it. That's question 21, 22 have already been answered on my TikTok, so I'll link that in the description. But oh my god, for now then. So we need to figure out, so he works out the sum of the numbers on these cards, records the result, he wants to know the probability of being an even number. So what could Ray do? Well, he could pick 3 even cards, he could pick 3 odd cards, he could pick an even and 2 odd cards, he could pick an even card and then an even card and an odd card, or an even card and an odd card and an even card. And you kind of see what I'm doing here. He could then pick an odd card, then an even card, then an even card, or an odd card, an odd card, then an even card, or an odd card, an even card, then an odd card, right? Those are his options that he could pick. Let me just check. Okay, so those are his options. We need to figure out which of these is going to give us an even number. It's kind of done by kind of like trial and error, just adding different even numbers. So if I make the even number in every case 2 and the odd number in every case 1, might as well keep it simple. Then we'll have 2 plus 2 plus 2 is 6, which is even. Then we'd have 1 plus 1 plus 1, which is 3, which is odd. And we're going to keep going like that, just kind of trialing and erroring. So 2 plus 2, because that's 2 ones, which is even, it's 4. And then 2 plus 2 plus 1 is odd. 2 plus 1 plus 2 is odd. 1 plus 2 plus 2 is odd. 1 plus 1 plus 2 is even. And then 1 plus 1 plus 2 is even. So therefore we have 1, 2, 3, 4 options of picking an even number, right? If we then go through and work out probabilities of picking those, that's the next step. So how many even cards are there? Well, there's 1, 2, 3, 4 even cards out of 9 cards, right? So that's the probability of picking an even card the first time. Look at this probability here. I'm going to multiply that by, because it's kind of conditional, picking one, then the next, and the next. And then going to then find the probability of this one here, which is take one from both of these, because I've taken one even out, therefore there's 3 left, and 1 card out, therefore there's 8 cards left. Same thing over here, take another card out, therefore there's 2 cards left out of 7 cards. And then it goes to the next even, that is then 4 out of 9, it's an even card, none have been taken out yet, times by number of odd cards, which is then 1, 2, 3, 4, 5 out of 8, because there has been a card taken out, just not an odd one. Times that then by, one of these has been taken out, and one of these have been taken out, 7. And then another even down here, we have, what do we have? 5 over 9 times 4 over 8 times another even, which is actually the first even in this case, 4 out of 7. And then last kind of situation, we have odd, 5 over 9 times even, 4 over 8 times another odd, which is not this one, 4 over 7. The bottom should always be the same, 9 by 8 by 7 on the bottom, and the top should depend on what you're taking out versus what you've already taken out. And then if we times all these fractions together, we get 1 over 21 for the first one, 10 over 63 for the second, 10 over 63 for the third, and 10 over 63 for the fourth, because these are all the same, aren't they? Just 2 4s and a 5. So then 10 over 63, and then the last thing we need to do is just add all them together. So we add 1 over 21 plus 3 lots, there's 3 of them, 10 over 63, which is then, what is that? 11 over 21. And that is your answer. And there we are. So yeah, if you want to see more difficult questions like that, there's a bunch more like on my TikTok with some walkthroughs and whatnot. But there we are. That is that. On we go then to the last question of the paper. Question 22. L is the straight line with equation y equals 2x minus 5. C is a graph with equation y squared equals 6x squared minus 25x minus 8. Using algebra, find the coordinates of the points of intersection of L and C. You must show, you're working. So if you see points of intersection on your kind of higher paper, especially this far through, this always means simultaneous equations. And we can't use the elimination method in this case, which is the one, you know, where like for simple equations like grade 5 kind of level, where you get the numbers the same on 2 of the equations, like the x is the same or the y is the same, and you take them away or you add them to kind of eliminate them. That's that method, but you can't use that here because this guy's way too awkward for that. It's got squares in him. No good, right? Therefore, our only other method is substitution. So I want to put this in here, right? I know that y, so it's minus 5, and there's y squared here, so I can replace this y squared with this guy here. So 2x minus 5 all squared, because it's y squared, and that's y, so I'm just going to square it, is then equal to 6x squared minus 25x minus 8. And if I square this, I'm going to get, square this first, so 4x squared, then times them together, which is minus 10x, double it, minus 20x, then square the last term, which is plus 25. Like a little hack for you to kind of expand them quite quickly if it's the same bracket twice. And then I'm going to leave this as it is, actually, 6x squared minus 25x minus 8. And then what I'm going to do is I'm going to simplify this. So I'm going to bring all of this over there. Because I want it's looking a bit quadratic-y, right? You've got an x squared, you've got an x, you've got a number. So I want to make one side equal to 0 so I can factorize it, or I can use the formula. So I'm going to make this side equal to 0 because this has the lowest denomination of x squareds. If I shove all this over there, I'm going to get 6x squared minus 4x squared, which is 2x squared. And I'm going to get minus 25x plus 20x, which is minus 5x. And we're going to get minus 8 minus 25, which is minus 33. And then from here, you can factorize this if you want to. Remember, timesing to get minus 66 and adding to make minus 5. You can do that if you want to. However, I think what I'm going to do is use the formula. Actually, this is 6. I was thinking this is 6 and 11, isn't it? Yeah. So if it's awkward, like say if you get ones like this that are really big numbers and you just can't be bothered to factorize it, then use the formula. Quadratic formula, that always works. You have to have a calculator for it. So it's paper 1, you're kind of out of luck. But if it's something like this and you can't be bothered, just use the formula. But this actually isn't too bad, actually. So I'm going to do, what is that, minus 11 plus 6. Then that is 2x plus 6 and 2x minus 11 equals 0. Simplify this to get x plus 3. Just divide both sides, like both of these, by 2. And then 2x minus 11 equals 0. And then this equal to 0 is x plus 3 equals 0. So x is equal to minus 3. This equal to 0 is 2x minus 11 equals 0. So 2x equals 11. So x is equal to 11 divided by 2, which is 5.5. Okay. So those are my 2x coordinates for the point of intersection. That's what Simultaneous equations are for. That's what they find. They find the points of intersection. So that is those two. So what I then need to find for the coordinates, right, I need to find y's. So I'm going to do what I normally do, Simultaneous equations. I'm going to put my numbers back in. If I change my colour pen to make it a bit easier to see, I'm going to have y equals 2x minus 5. Is a top equation because you kind of be a fool who's anything else. This bottom one is just nasty, gnarly. Don't want to use that one. This one's much easier at the top. So I'm going to have y equals 2 lots of x, which is minus 3. So 2 lots of minus 3 minus 5, which means that y is going to be minus 6 minus 5, which is minus 11. So this coordinate with this x here is going to be minus 3 minus 11. And then for the other coordinates, I'm going to have y is equal to 2 lots of 5.5 minus 5, which is y equals 2 lots of 5.5 is 11 minus 5. So y is equal to 6. And there we are. So then for this one, shuffle it down a little bit, I get the coordinates 5.5, 6. And there we have it. Those are your 2 coordinates, or points of intersection. And there we are. And there we are, that was June 2022's paper 3. So now I've done all 3 papers from this set, so I'll put them all in a playlist of all my math papers that I've done and put the playlist at the end, like in the end title card place. As you should see it kind of popping up sometime around now. So if you want to watch some more of those videos, then feel free. Also my TikTok, I've been posting quite a lot on there. Some hardest question stuff, some kind of top tips, some I noticed bits and pieces, I guess, some topic walkthroughs, things like that. So if you want to follow that or have a little look, then I'll put that in the description as well. This paper was actually pretty good. I really enjoyed this paper. I think it wasn't as fathy as some of the other ones are. And I know, I quite enjoyed it. How did you feel about it? How did you feel about this paper? Please, let me know in the comments down below. If you have any recommended topics that you want to go through, put them down. I'll make a video on them. Etc. You know the drill, all that stuff. Like, subscribe if you enjoyed it, all that stuff, bits and pieces, blah, 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 blah. So yeah, I'll leave it there. I'll stop rambling. Have a lovely rest of your days, evenings, mornings, what time you're watching this. I will hopefully see you in the next one. So I'll see you then. Bye!